Bienvenidos, Hushamadid, and welcome UMGC learners from the CMIT-455 Section 6380 course. This is the CCNP ENCOR version 8 course from the Cisco Networking Academy curriculum, and this is the spring 2021 semester. In this video tutorial, we're going to be stepping away from Packet Tracer to take a look at virtual routing and forwarding, and specifically VRF-Lite. And I'm going to talk about the differences between VRF and VRF-Lite, and we're going to do a deep dive here. So over the next 5 days, we're going to be configuring VRF-Lite between a series of routers. And I'm going to be demonstrating to you a series of different use cases. And so each day for the next 5 days, we're going to be digging into this topology right here, where we're looking at layer 3 segmentation using VRFs and specifically VRF-Lite throughout this environment. And so each day we're going to deal with a configuration between two routers. And today we're going to start with our first use case, which is between router 1 and router 2. Now, this use case is when we have dedicated an individual physical link between the routers, in this case gig 00, gig 01, and gig 02, to service each of the VRFs. Now, virtual routing and forwarding, you will sometimes hear referred to as VPN routing and forwarding. So virtual private network routing and forwarding. Now, that is a less common term, but it is very applicable to what VRF and VRF-Lite are allowing us to accomplish. And that is doing the same thing that VLANs do for layer 2, except we're doing it with layer 3. Remember that a VLAN can take a single physical switch and carve that switch up into multiple logical layer 2 broadcast domains, layer 2 VLANs, layer 2 subnets. And that's what we're going to be doing with VRF. And specifically VRF-Lite is we are going to be doing layer 3 segmentation. Now, the first thing I want to address is the difference between VRF and VRF-Lite, because there is a slight difference. Now, the first difference is that VRF is typically used, and this is a typical accepted definition, is that VRF is used with MPLS. And VRF-Lite is not used with MPLS. Now, let me expand on that, because when you're saying that VRF is not used with MPLS, what you're really saying, and what the technical difference really is that VRF is using multi-protocol BGP, and we're using route distinguisher values. And it's those route distinguisher values, which I'll demonstrate for you here, and multi-protocol BGP that give us VRF. In other words, when we're using VRF and we're defining route distinguishers and we are using multi-protocol BGP, that is VRF. VRF-Lite, on the other hand, is creating VRFs, and they're created in almost the same way, except we do not have route distinguisher values and multi-protocol BGP. So it really comes down to whether or not we're using VRFs and multi-protocol BGP. That is really the differentiator. If we have multi-protocol BGP and we have route distinguisher values, we're using VRF. If we do not have multi-protocol BGP and we don't have route distinguisher values, we're not using VRF, or I should say we're using VRF-Lite. Now, you might be asking yourself, well, wait a second, what if I'm just doing BGP over VRFs? Is that VRF or VRF-Lite? You can do BGP, not multi-protocol BGP, but you could do BGP for IPv4, for example. and do that over a VRF, and that is VRF Light. So again, you'll hear people say VRF means you're using MPLS. What they're really saying is it means you're using MPLS because you're using multi-protocol BGP and you're defining route distinguisher values, right? So again, subtle differences, but important, because here we're doing VRF Lite, and I'm actually going to be configuring OSPF as the routing protocol for each of these VRFs. Now, remember I said VPN routing and forwarding. That is also not as common, but it is used to describe what you're doing with the VRFs. We're creating virtual private networks. Again, we are taking a single individual router, and in this single individual router, we're creating in the single physical router, we're creating a virtual router. So we have router red, we have router blue. I'll put a little B in here. We have router blue, and then we have router green. Now, what's interesting about each of these virtual routers that we have running here, right, through VRF, is that the interfaces, the routing information database, the RIB or the routing table, and the forwarding information database or the FIB are mutually exclusive. In other words, we sort of have this big global routing table that the router is made up of. And let me do this. Let me take a black line over this here so that it doesn't confuse. The colors don't get confusing because we have the red VRF. So let's say this is the physical black router here. And inside the physical black router, we have the red VRF, the green VRF, and the blue VRF. Now, an interface can only belong to an individual VRF, and that is a physical interface, a switch virtual interface, because we can do VRFs on switches, a sub interface. Those can only belong to a single VRF at a time. And so you will see interfaces being moved from inside of the global routing table when we associate those with the VRF we're configuring and put that interface into that VRF. Then the interface disappears from the global routing table. And again, this would be my global routing table here, because we'll always have that. In fact, think of it like this. When you log on to a router and you've taken the router out of the box, you turn the router on and you log in, you are in the global context for that router. It's not until you start creating Vrfs, which, and again, it's VERF is kind of a short way. That's the phonetical spelling. Sounds like Nerf, like the Nerf guns, except with a V, Vrf. And you'll hear people refer to, oh, the green Vrf, the blue Vrf, the red Vrf, right? It's just simply a way of differentiating the traffic. And you might be asking yourself, well, why in the world would anybody ever do this? Think of a multi-tenant scenario, where you have a building with multiple tenants, and those tenants have their infrastructure. Maybe it's delineated by floor, right? But you can have all of company A, who might be red, company B, who is blue. We'll say company R for red, company B for blue, company G for green. All of their traffic flows over this entire infrastructure here, and the traffic is never co-mingling together. It is 100%, from a layer 3 perspective, mutually exclusive from all other traffic. In other words, I don't see customer red's routing information in the customer blue VRF, and the customer blue VRF doesn't see customer green. So none of these VRFs will see the layer 3 RIBs, FIBs, interfaces for any of the other customers. Now, the reason I wanted to put this supplement together is that Chapter 6 in the official certification guide talks about very briefly virtual routing and forwarding. And this is an extremely important topic, not only from the exam perspective, but more importantly, in the real world, where this is done all the time, where we take a single physical router and we virtualize it by creating Vrfs, virtual routing and forwarding instances that have their own interfaces, their own ribs and fibs. They're mutually exclusive, and it allows us to provide layer 3 segmentation. And so one of the things about VRF-Lite, and you'll remember I said, or VPN routing and forwarding. Remember, VPN, when people hear that, they typically think right out of the gate encryption. But I'm here to say that VPN, depending on the context in which you're talking about it, does not imply necessarily that encryption is involved. This is a great example. I'm going to be creating 3 virtual private networks, one for company red, company blue, company green, and they are going to share this topology. And none of their traffic is going to commingle. And you're going to see that this is easily achievable. And so our focus in this video today will be this configuration work right here. And again, the loopbacks will configure in turn. We're going to configure a loopback, and you'll notice it's the exact same IP. But we're doing it for loopback 1, 2, and 3, meaning that these would have to be in VRFs. And so loopback 1 will be red, loopback 2 is going to be blue, loopback 3 is going to be green. And this is to show you that I can use the exact same IP addresses as long as they're not in the same routing context. And again, all these customers could be running the same IPs. I decided to do it from a loopback perspective and to give different subnets for the red, blue, and green networks on either side of our topology. So let's go ahead and dive in, and we'll talk a little bit more about VRFs, and we'll talk about the configuration aspects. So again, these are physical Cisco routers from left to right. The first 2 we're going to be working on are 3945Es, so ISR G2s. And I think what I put down here is I wanted to say, I just saw this here, 0, 1, and 2. So gig 00 is going to be VRF red, gig 01 VRF blue, gig 02 VRF green. So let's go ahead and dive into the command line. And actually, before we do that, the best analogy that I can give you in an image for VRFs is the following. Take a look at this. Over here on the left, we've got the red lane, the orange lane, the yellow lane, the green lane, the blue lane, and I'll say the dark blue, maybe purple lane over here. But this image drives home the concept of the VRF. It is the segmentation of each of these individuals into their own lanes based on in our case, a color. You don't have to call them red or blue or green. I mean, you can name them anything you want. And the names are case sensitive, but this should drive home what we're trying to achieve, is that everybody is in their own lane, right? Okay, so let's dive in here and let's jump onto router 1 and router 2. So here on router 1, we're going to go from user exec to privilege exec, and I'm going to say show IP interface brief, because as I had indicated, the loopback 10, 20, and 30 networks, and these are simulating network segments that would be hanging off of router 1. Now, let's create our VRFs first. And VRF creation, especially with VRF-Lite, very straightforward and very simple to achieve. Now, there are 2 ways to do this. Since we're dealing with IPv4 and IPv4 only, I can say IP VRF, and if I do a question mark, you can see it's the VRF name. Now remember, these names are case sensitive. So this VRF name is not the same as that VRF name, is not the same as that VRF name. They're case sensitive, but we're going to go all caps with ours. So I'm going to say IP VRF red, and hit enter. Now, when we come in here, you can see we've got all kinds of options that we can pick from. You'll notice that we could set the route distinguisher. Now remember, the route distinguisher values, as similarly to the route target values, that's when we would be talking about VRF and not VRF Lite, because we would be running with VRF multi-protocol BGP. And again, that's a little outside of the scope of this video, but keep that in mind. We don't need to define either of those. So I can simply say IP VRF red. And so the red VRF has been configured. So if I say do show VRF, we see that we have a red VRF. The default route distinguisher is not set because it doesn't have to be, because we're doing VRF Lite. Lite meaning we're not using multi-protocol BGP, which adds a heavy burden to the administrator to get that set up and configured. And then interfaces. We don't have any interfaces in VRF red. So there's VRF red. Let's say IP VRF blue, and then IP VRF green. So I've just created 3 VRFs. Do show VRF. And there are the 3 VRFs. And because I said IP VRF, and this again would sort of be considered the legacy syntax, but you do see it in use, I'm limiting myself to IPv4. But I'm going to show you how we kind of bail out of this and bring ourselves up to the latest and greatest configuration. And I'll do that shortly. So you can see we're limited to IPv4. If we were doing IPv6, we would kind of be stuck right here if we don't uplift and upgrade the VRF configuration syntax. So now that we have the VRFs configured, let's take a look here at the loopback interfaces that we were just working with. Loopback 10, loopback 20, and loopback 30. Well, I know that these are supposed to be in their own VRFs, right? In their own routing information databases, their own forwarding tables, their own routing tables, right? But let's take a look right now and say do show IP route. Do show IP route. And what do we see here? Well, we see that all of those networks and those interfaces, loopback 10, remember, those are seen as directly connected interfaces, the loopback interfaces. We see they're all in the global routing context. And when I say context, that is synonymous with table. So global routing context is global routing table, right? And that is where we're at right now. We are in the global table. And so here's what's about to happen. I'm going to go into each of these loopbacks, and let's start with interface loopback 10. And let's go ahead and say VRF forwarding. And this is how we place, and take a look. And this is what I like about the latest and greatest iOS, is that it sort of knows the VRFs that have been created and is providing me context-sensitive help to make the choice to say, oh, that's right, 10 is going to be red. So I would say VRF forwarding red. Now watch what happens when I hit enter. You can see that it says use IP VRF forwarding command for VRF red. And that's because when we initially configured the Vrf, we said IP VRF red. So what we're doing here is we're having to follow this legacy syntax. So now I'm going to say IP VRF forwarding, and let's do a question mark, and you can see it still helps me out. But now we're going to see something else happen. We've got the correct syntax here, but watch what takes place with loopback 10. Interface loopback 10 IPv4 disabled and addresses removed due to disabling VRF red. And what this means is we've removed this directly connected loopback interface from the global routing context, and we've placed it into the VRF red routing context. And the reason that the address gets removed is because there could be, in the VRF red, a duplicate address. We might already be using that address because remember, if we have our own routing table and our own interfaces and our own forwarding information database per VRF, including the global VRF, then I can have the same IP subnets that I'm using across all the VRFs, which is theoretically possible. And so that is what has happened here, because if I say do show IP route, take a look, where did loopback 10 go? When you say do show IP route, you're asking the router to show you the global routing context. But we've created 3 virtual routers inside of this physical router. And you might think of it as an ESXi host. The physical router is an ESXi host, and we're creating VMs. And those virtual machines are virtual routers. And that's kind of what that's really what we're doing here, right? And remember, all of these virtual contexts, the Vrfs that we're creating, they all still share the same physical resources from a memory and CPU perspective. There's no way for me to carve up here, give VRF Red 80% of the resources. And that's kind of where the VMware discussion breaks down, is I'm not able to carve up CPU and memory resources per VRF here, right? You can't do that. So everything we're doing is sharing those physical resources, okay? All right, so we lost it. So then the question is, well, how do I see it, right? So it's do show IP route VRF red. And you can see right here that gateway of last resort is not set. Here's the routing table. And so the question is, well, where are the interfaces that I put in there? Because if I say do show run int gig 00, you can see that it's shut down. We have no IP address, and hold on. Oh, I'm sorry, not gig 00. I apologize. I was like, wait a second. I did not do that. We did interface loopback 10. My apologies. I was thinking gig 00 already. So if I said do show run interface loopback 10, you can see that there it is. Loopback 10 exists. It's associated with the red VRF. And so now that I'm in that interface, now I can put the IP address back on here. And so we're going to say IP address 10.1.1.1 for router 1. It's a /24. And so now we do have an interface on here. So if I say do show IP route VRF red, now we see where the loopback 10 is at. Again, do show IP route, that's the global routing context. So loopback 10 is not in the global routing context. 20 and 30 are, 10 is in the VRF red routing context, the VRF red routing context. All right, so now let's go ahead and finish up here. Let's get into interface loopback 20. I would say IP VRF forwarding and then blue. Now again, the addresses are going to get removed, so I've got to go into interface loopback 20 and say IP address 10.2.2.1, again, that last octet meaning router 1, and we're going to make it a /24. So now when I say do show IP route, we can see that the only thing left in the global routing table is loopback 30. But if I say do show IP route VRF red, we see loopback 10. If I say VRF blue, we see loopback 20. And so now let's get into that loopback 30, and let's say IP VRF forwarding green. And so then again, we've got to put the addresses back on there. So IP address is going to be 10.3.3.1 for router 1, and then a /24, do show IP route VRF green. And so now what I've done is I've virtualized this physical router into 3 Vrf virtual routers, and then consider the physical router, the global routing context, as a 4th. So I'm supporting, let's say, 3 customers or 3 tenants, right? And maybe it's a multi-tenant situation. And so then how would I manage these routers? Well, I would do that in the global routing table, right? And that's how you could use the global routing table. So now these interfaces, these directly connected virtual or logical loopback interfaces are now in each of the VRFs to which they belong. And so if we come back to our drawing, we can see that this has been done. But that's not good enough because remember, these companies, red, blue, and green, we are going to stretch them all the way across this environment using different techniques every time. Here we're using physical interfaces. Here, we're going to use a single interface and carve it into sub-interfaces. Once we hit the middle, we're going to be doing back-to-back frame relay across a serial interface. Here, we're going to be doing Gre tunnels, and you can see red, blue, and green, and they're inside. I put black on the top and the bottom to make it look like they're tunnels, right? So those will be Gre tunnels, and then we have a special surprise here at the end. So let's come back to router 1, and now let's deal with these loopback interfaces. Because here's where you're going to see that it doesn't matter if I use the exact same IP address if they're in different routing contexts. So I'm going to go into interface loopback 1. I'm going to say IP address 1.1.1.1. We're going to make it a /32. And now watch what happens. If I go into interface loopback 2 and I tried to say IP address 1111 and make it a 255/32 host route, when I hit enter, what's going to happen? Yeah, we're going to get this error message saying that that overlaps with loopback 1 because in what routing context are both of those entries attempting to be made? Again, one of them was made, and that's why we see the error message we see, but it's because both of those commands are indicating that what we're going to be doing is in the global routing context, not in the VRF. So what I would have to do is go into interface loopback 1 and first say IP VRF forwarding red. Now you can see it remove the IPs. And this is, again, to show you what you may run into and what's going to happen and explain why that is happening. Again, it removes the IP off that interface as it transitions that interface into its new routing context, VRF red. Now it's up to me to put the IP address back on here, 1111, and then make it all 255s. Whoops. For /32. So now when I go into interface loopback 2, what I would want to say first is IP VRF forwarding blue, and then say IP address 1111 and make it all 255s. And now we do not see that error because if I first put the interface into the routing context to which it belongs, only if that prefix was in this routing context would I see that error. Because I'm doing this, again, in my own RIB, my own routing database, my own forwarding information database. It's inside that VRF, right? Think of it as like a little hermetically sealed bubble inside that physical router where I can go ahead and do the same thing in red that I'm doing in blue that I'm going to do in green. And now we're going to go into interface loopback 3, and I'm going to say IP VRF forwarding, again, remembering that we are using the legacy context here, IP VRF forwarding green, and we're going to say IP address 1111 and make it all 255s. Whoops. In fact, I could say interface loopback 0 for the global routing space. Oops, and I forgot my ADD. So now, let's take a look at the routing table here. Do show IP route. Here's my global routing context. And there's loopback 0, 1111, because each interface can only belong to a single VRF. And that's a physical interface, a sub interface, a switch virtual interface, right? A back-to-back serial sub interface for back-to-back frame relay. So again, we see that there is the global routing context. Here's the VRF red routing context with the exact same prefix and subnet mask. What about VRF blue? And now let's look at VRF green. And you should hopefully have a feeling right now, a sense that, okay, I get this. I see what's going on. Things are being divided up here into virtual routers on this single physical router. So now, what about the links between the routers, right? Because we configured these little simulation networks over here that are different. Then we configured the loopback address that is the same to identify router 1, because this is going to be, we'll use this as our router ID maybe, or we'll use it as reachability for reachability in each of the VRFs. But you can see that they're all the same, but they're all in different VRFs. Okay, so we're going to do the same thing, or much the same thing, with these physical interfaces between the two routers. So let's get on to router 1, and let's go ahead and say interface gigabit Ethernet 00. Now remember, I don't want to put the IP address on here first, because as soon as I associate it with the VRF, it's going to get erased, because it moves it into that VRF. So what do? IP VRF forwarding. Again, I'm using the legacy syntax. We're going to circle back and address how we uplift the config. And then from here on out, I'll use the actual address family syntax. So IP VRF forwarding red, right? And then I could go into interface gigabit Ethernet 01 and say IP VRF forwarding blue, and then go into 02 and say IP VRF forwarding green, right? So now those interfaces have been added into the VRFs, but now I need to put IP addresses on there. Well, remember what I said. Do I need to try to figure out 3 different subnets to use here for these transit segment links? And the answer is no, and this is another benefit we've already seen with VRF, is that it allows me to use the exact same IP addresses in each of the different VRFs. And so let's do that. Let's start with gig 00. I'm going to say IP address 169.254.1.12, because it's between router 1 and 2, .1 for router 1. And we'll make it a 24. Now, this is how easy this is going to be. I'm going to go into int gig 01. I'm going to hit the up arrow twice and hit enter. I'm going to go into int gig 03, and I'm going to hit the up arrow twice and hit enter. That's it. We're done. So we use the exact same IP address and subnet mask length for all 3 of those physical interfaces. And we can do that because do show VRF. And we can do that because they are in VRFs. And you can see here, it looks like it alphabetically lists them out for us. And so what interfaces belong to the blue VRF? Loopback 20 and 2 and gig 01. Which interfaces belong to the green VRF? Loopback 30 and 3 and gig 02. What about the red VRF? 10 and 1 and gig 00. So again, an interface, just like when we have access interfaces and we say show VLAN brief, you don't see an access interface listed next to multiple VLANs because it can only belong to a single VLAN. Again, we're going to leave the IP phone conversation out of this for now. But with a host access port, it's only listed next to one VLAN. And the same is true here, right? Lots of similarities between a VLAN at layer 2 and what we're doing here with a VRF at layer 3. Now, I've dedicated physical interfaces here, right? And this is the first use case that we're going to address is, hey, I've got plenty of interfaces between these 2 routers. And you know what? Traffic could be pretty heavy between these 2 routers. So let's dedicate individual gigabit Ethernet interfaces. This is the first use case. So now we need to address what's going on over on router 2, because we haven't done any configuration work over here on router 2. So let's get into global config. And if we look back at our diagram, let's go ahead and create the VRFs first. And so what we're going to do, and I'm going to show you how to do it. So here's the new, I shouldn't say new, this has been around for a while, but this is how you're going to configure your VRFs. You're not going to be using that IP-VRF forwarding. That command is a legacy command for IPv4 only. You're going to say VRF definition and then the VRF name, right? Now, this puts us down, and you can see we have sort of a trimmed down version of options here. Route distinguisher is still here. Route target is still here. We are doing VRF Lite, meaning we're not running MPLS, and we are not using multi-protocol BGP. So these values are meaningless in a VRF Lite scenario. But this command right here, because VRF definition supports multiple address families, or AFs, meaning I can support IPv4 and IPv6. And so if I'm supporting IPv4, I would say address family IPv4, and unicast is the default, right? So even if I type that out, if I hit enter right here after the 4, that is the same thing, right? So when you say address family IPv4, it is implied that it's unicast. That's the default. If you're doing multicast, you need to specify multicast. And that's the only extra command if I'm only doing IPv4. But let's say, let me exit up one level, address family IPv6. So I'm going to make both of these, even though we're not doing IPv6, both of these, I should say, I'm going to activate both address families for the red, the blue, and the green VRFs here. So now we're going to say VRF definition blue, address family IPv4, exit, address family IPv6. And then we're going to say VRF definition green. I could even hit the up arrow, address family IPv6, and then we would exit out and then find the IPv4. And then let's go ahead and see what we've got. Show VRF. And you see the difference here. This would show you the protocols, and actually I think it's the control key if I hold that down. No, the option key. Yeah, the option key limits me to a column. So you can see here that the protocols that are supported now state IPv4 and IPv6. We don't have any interfaces though, and so that's going to be a problem. We need to put interfaces into the VRF. And so if we look at router 2, we can go ahead and configure loopback 1, 2, and 3, and they all have the same IP address and the same subnet mask length. So let's get into global config, interface loopback, and let me make sure we're 1, 2, 3. Loopback 1, oops, sorry, and here's where you would say VRF forwarding, right? VRF forwarding, not IP VRF forwarding, but VRF forwarding. It's here where the definition of the supported protocol is defined, right? I don't have to say IP VRF forwarding. I say VRF forwarding red. IP address 2.2.2.2, and then we'll make it a /32 host route. Oops, sorry. One too many twos there. There we go. Interface loopback 2. Again, VRF forwarding, and what did I say? Blue is going to be the second one. IP address 2.2.2.2. I keep putting too many twos. I'm sorry. 255, 255, 255, 255. And then interface loopback 3. And we're going to say VRF forwarding for green. And I can just hit the up arrow, actually, and get that same IP address in there. That way you don't have to watch me create a bunch of typos. All right. So now do show VRF. Take a look at what we've got. We've got the loopback interfaces in there. And that's great, but what we don't have that we're going to need in there are these physical interfaces. And it's the same physical interfaces on router 2, gig 0001 and 02. That'll be the red, the blue, and the green VRF. So let's go ahead and do that. And again, we're going to use the exact same IPs on each of these physical interfaces, but the last octet will be .2 for router 2. So let's get into int gig 00. do show IP interface brief. And yeah, these are administratively down, so I'm going to have to bring them up. So we'll say no shut right out of the gate. And then I'm going to say VRF forwarding red. And then I'm going to say IP address 169.254.12 because it's between router 1 and router 2. .2, we'll make it a 24. And there we go. And then I'm going to go into interface gigabit Ethernet 01, VRF forwarding blue. I'm going to hit the up arrow a couple times, and I'm putting the same IP on there. Interface gigabit Ethernet 02. And again, these transit segment links, we're using these APIPA 169 addresses, which is a common thing to do because you're not routing to the transit network. You would be going to either something beyond the transit network or to a loopback address, and these are unroutable on the public internet, right? Another reason that you would use these as your transit links to make it more difficult for somebody to get to the device. And we're going to say VRF forwarding green, and then the up arrow a few times, and no shut. Let's make sure do show IP interface brief. We'll bring these up and make sure that all of those are up in gig 01. Interface gigabit Ethernet 01. We'll say no shut. We'll say in. We'll say write mem. We want to save that configuration. And then we're going to come over here to router 1 where do show IP interface brief. I'm pretty sure we left these all administratively down. We did. So interface gigabit Ethernet 00, no shut. Interface gigabit Ethernet 01, no shut. Interface gigabit Ethernet 02, no shut. And so now all these interfaces are up. We've got our simulation network segments configured and up and in the right VRFs. We have our loopback addresses for each of the routers configured as well. So now let's test connectivity. And remember, show IP route. What do I see in the global routing context? I see just that, right? The loopback 0 address. That if I was to run OSPF, maybe I use that as my router ID, maybe I don't. But again, it's there. So what am I trying to ping? Well, let me see. Can I ping 169.254.12.2, which is just, router 2? And let's see what happens here. Well, what we're going to see is that these pings are each going to time out because the ping command is also VRF aware. In other words, if what I'm trying to ping is in a VRF, I need to specify that in the ping command. And you can see ping, there's the VRF. It wants the VRF name. So let's start with red. And now it wants the IP address. So ping VRF red 169.254.12.2. So do I have reachability here in the red VRF between these routers? Outstanding, we do. What about in the blue VRF, right? We want to make sure that that one works as well. And we do. Outstanding. What about in the green VRF? And we do. After a couple of ART packets here, and let's make sure that I brought that interface up. All right, so we don't, but that's okay. Show IP interface brief. Did I bring up gig 0? I see what I did here. Wow. So I just created a whole bunch 0001. So for 03, and actually not a whole bunch of work. So here's the problem. You can see that I wanted to do that to gig 02. Let's check router 2 and make sure that show IP interface brief. All right, I did not commit the same mistake on router 2. So, hey, this happens, right? So how do we get out of here? Well, let's say default interface, gigabit Ethernet 03. That sets that interface back to its default. If I say do show run interface, gigabit Ethernet 03, there it is. That was when you first turn the router on, brand new out of the box, that is the default configuration for that interface. Now, if I say do show IP interface brief, what do we see? 03's unconfigured, right? So now let's make the right configuration change here, gigabit Ethernet 02, And let's say IP address 169.254. We don't want to do the IP first, right? We want to say IP VRF forwarding. Again, legacy syntax over here on router 1 so that you can see both ways of this being done. Now we put in the IP address of 169.254.12.1 for router 1, and it's a /24. And we say no shut. And now we say in, and let's say show IP interface brief. And there it is. And it looks pretty good, right? And if you were to see this output right here, from here down, right? What's the one thing that you can assume immediately based on the IP address values that are being used not only for the physical gigabit Ethernet interfaces, 0, 1, and 2, but for the loopback interfaces? Yeah, those have got to be in VRFs. They've got to be in Vrfs, or else you wouldn't be able to do that. So let's say show VRF, and we've got some options here, right? We can say show VRF brief, but we've already seen that. That's the same as show VRF, right? Or we could say show VRF detail. And this is going to give us a whole bunch of additional information. Specifically, default route distinguisher not set, right? Because we don't have to use the route distinguisher values when we're doing VRF-Lite. Now, what I like most is this right here. Old CLI format supports IPv4 only. If I came over to router 2 and said show VRF detail, new CLI format supports multiple address families, because on the router 1 config, I said IP VRF and gave the VRF name. That's the legacy old syntax. Here on router 2, I said VRF forwarding, or I'm sorry, VRF definition. That is the address family format. And you can see here, address family IPv4, address family for IPv6. All right, and so that's the detail command. So now let's do that final test that we were doing over here. And let's say ping VRF green 169.254.1.2. And so everything is working now. We've got reachability across all the VRFs. So now let's configure a routing protocol. We're going to configure OSPF because, again, we've just come off a number of OSPF videos, but OSPF is a VRF-aware routing protocol, as are any of the serious routing protocols are VRF-aware. Even RIP is VRF-aware. So OSPF, EIGRP, BGP, and RIP, right? Those are all VRF-aware. So here we are. Let's go into global config. I'm going to say router OSPF. I'm going to give the process ID 1 for red. We'll use 2 for green. I'm sorry, 2 for blue, 3 for green. But remember, it's VRF-aware, and I can't do it in the global routing table and expect the VRFs to get the configuration, right, or to understand the configuration. I have to make it VRF-aware. And so I just simply say router OSPF 1 VRF red. And it's in here that I can say router ID. And again, we're on router 1, so we'll say 0.0.0.1. I'll say passive interface default, and we'll say no passive interface loopback, or I will leave the loopback passive. We'll say no passive interface gigabit Ethernet 00. Because remember, it's 00 that is in the red VRF. And it's across that transit link that I want the adjacency to come up between router 1 and router 2 for VRF red. So we've done the passive interface configuration. Now we can do the network statements. So 10.1.1.0000255, that's our, and we'll make it area 0. And that's our, think of it as like our pretend simulated network behind router 1. Let's get the loopback interface advertised. And remember, that is a /32, and we'll put that in area 0. And then the network for the 169.254.12.0 is a /24. Now, could I have said 12.1 and done quad zeros? I absolutely could do that, and let's go ahead and do that. So you've got the 10 network with a wildcard mask, and we have another statement with the specific IP for that physical interface. So we've got that configured. Let's say do show IP OSPF neighbor. What is that going to show me? Well, I don't have any neighbors. What about do show IP OSPF interfaces? And take a look at that. It shows us the interface for loopback 10, and we see the interface for loopback 1, and we see the gig 00 interface. So we see all of the interfaces that we've added into the OSPF VRF-aware routing process for VRF Red. Let's go to the other side, and we'll bring the adjacency up here between these two routers. So we'll go into global config, router OSPF 1 VRF Red, meaning we're going to say router ID is 0002. We're going to say passive interface default, no passive interface for right now, gigabit Ethernet 00, and then we'll add our network statements in. So here it's 2222. For the loopback address, it's a /32, area 0. Then we have, and I think that's it, the loopback and then the transit segment. And then we're going to say network 169.254.12.2, and we'll do a quad 0 on that. And again, that is something to get familiar with in terms of a best practice and something that you will be asked to do if you move into the CCIE realm of things. So take a look at that. From loading to full, do show IP OSPF neighbor. And there it is. We have an OSPF neighbor, and it's in VRF Red. Now, what if I say do show IP route? Am I going to see those networks that were advertised? Well, I don't. Remember, do show IP route VRF Red. I have to specify, and now look what I see. Via OSPF, I'm learning about router 1's loopback. Via OSPF, I'm learning about that make-believe network, right? That network segment that's being simulated by loopback 10. I'm seeing that. So now I'm actually running OSPF for VRF Red. Let's go ahead and do the same thing for VRF green and VRF blue. So now here's where it's going to get a little interesting. What if I was to say router OSPF1 VRF blue? What do you think's going to happen? I've used process ID 1 for VRF red. So VRF specified does not match existing router. Do show VRF. Well, that's funny because I have a blue VRF right here. So the problem is I'm trying to go back into the same OSPF process ID for a different VRF. So router OSPF2 VRF blue, and that works, right? So making sure that we're using the different process ID numbers here, right, is going to be important. So let's go ahead and say router ID 0002. We're going to say, oh, and you know what? That's right. And the router ID value, even though we are using VRFs, it's already being used. So then we'll just say 22 here, and we'll just for blue, and then 222 for green. All right, so we'll set that. We'll say passive interface default, and then we'll say no passive interface gigabit Ethernet 01. And then we'll put our network statement in here for the 2222. We'll use area 0. And then we'll put a network statement in for the 169.254.12.2 for area 0. And then let's go ahead and say router OSPF3 VRF green. And then we're going to say router ID 000.222. And then we're going to say passive interface default, no passive interface, gigabit Ethernet 02. And then we're going to add our network statements in. We're going to make that 2 network reachable in this VRF, area 0. And then we're going to set it up for the transit link 169.254.12.2. And we'll do the quad zeros and then area 0. We'll say end because we're done with this router at this point in terms of configuration, router 2. Now let's come back over to router 1. And let's go ahead and bring the adjacencies up for router OSPF2 VRF blue. The router ID here would need to be 000. If I put 1, we're going to get that message saying it's already in use by process ID 1. So we'll simply say 11. I'm going to passive interface default. We're going to say no passive interface gigabit Ethernet 01. And then our network statements, we want to make sure that that loopback 0 address or loopback 1 address is reachable, area 0. And then our transit segment to bring up the adjacency 169.254.12.1. And we'll do our quad zeros here and area 0. And we should see the adjacency pop up, and there it is. And now let's say router OSPF3 VRF green. And we'll do the same thing. Router ID 0.0.0.111. And passive interface default, no passive interface gigabit Ethernet 02. And then a network statement. And you know what we didn't advertise? We'll have to go back into the VRF blue because I left off VRF blue's 10 network. So network 10.3.3.0. So we'll put in the network specification here with the wildcard mask and then area 0. We'll do our loopback address that we want to have advertised, area 0. And then our transit segment, 169.254.12.1 with quad zeros, area 0. But then let's go back into router, and there it is. The adjacency is up. So we'll say router OSPF 2 VRF blue, and we'll add a network statement in there for that 10.2.2.0 network, which is a /24 area 0. All right, so let's say write mem, because we don't want to have to reconfigure that tomorrow when we go to set things up. So now all of our VRFs are set up. All of our OSPF configurations are set up between router 1 and router 2. So what does that look like? I say show IP OSPF neighbor. And you can see that there are our different neighbors. What about a show VRF? Right, so there's our VRF information. What about show interface? And I believe, if I'm not mistaken, or there's another command I'm thinking of here. Show VRF, is it interfaces? Show VRF. Yeah, there's another command that's in my head right now that I don't think it's counters. Yeah, and so here it shows you the number of VRFs supported. All right, so can I ping? And let's come over to router 2, and let's see what it sees. Show IP route VRF red. It should see the 10 network, and it should see the loopback address. What about show IP route VRF blue? And so now all 3 of these customers using similar IP address information are all running mutually exclusive from one another across these 2 physical routers on which they're both using, right? So, or I should say they're all using. And so let's take a look at the green VRF. And there is the green VRF. And again, we've got all of this reachability information. So let's test. Can I ping VRF green and get to the 10.3.3.1? Absolutely. Can I ping VRF blue and get to the 10.2.2.1? Works like a champ. But what if I ping VRF blue and I try to go to the 3.3.3.1? Why does that not work? Because that subnet 10.3.3.0/24 is not associated with VRF blue. It's associated with VRF green. And so that proves right there that the routing tables and the forwarding tables, those things are all kept separate. Now let's do our final ping here to 10.1.1.1, and let's say ping VRF red. And that's usually what you forget, 10.1.1.1. And we've got connectivity. So we're running OSPF between these 2 routers. What if I say show IP Ceph? Is there a VRF option with Ceph? Because if I say show IP Ceph, here's what I see. I'm seeing the forwarding information database for the global routing context. If I wanted to see what the red context look and take a look at that. Much different look than the global routing context, right? So show IP VRF red, show IP VRF green, show IP VRF blue. Those are where the FIBs, the forwarding information databases, are going to be for each of the VRFs. Remember, they're mutually exclusive from each other, right? What about the adjacency table? Show adjacency. Is there a VRF option here? There's not. But what happens if I say show adjacency and I hit enter? Well, we see that information for each of the interfaces, right? What about show adjacency detail? And we can see for each of the interfaces, this is what each of those interfaces is seeing. And so I don't need to use the VRF option to see the adjacency table, but the forwarding table we absolutely do, right? So very, very important. In fact, if I say show adjacency summary, you'll notice that it's just going to give us some summary information here, that we have 3 adjacencies, and that these are IP adjacencies, which is why you see that at the very end here, the 0800 indicating the IP protocol. And then the MAC address is in here as well. Remember that for that interface, and indicating that that interface is using ARP, or is ARP capable. All right, so we've got everything set up here between router 1 and router 2 for physical interfaces with this VRF configuration. And so what we're going to be doing tomorrow is we're going to be looking at router 2 connecting to router 8. And so it's going to be from Gigabit Ethernet 03 on router 2 to Fast Ethernet 01 on router 8. And we're going to be using sub interfaces to make that happen, to show you that we can go from physical interfaces to sub interfaces to back-to-back frame relay. And as long as we are each step along the way defining the VRFs to which each of those physical or sub-interface links belong, or GRE tunnels belong, that traffic will continue to transit the correct links. All right, so thank you so much for watching this supplemental video tutorial on virtual routing and forwarding, and specifically we're looking at VRF Lite. Remember, VRF implies we're doing multi-protocol BGP with route distinguishers and MPLS. VRF Lite means no multi-protocol BGP, right? And we could put route distinguishers in there, but it's not buying us anything. So it's better to leave them off to not cause confusion, that somebody looks at that and says, oh, they've got route distinguishers defined here. Maybe this is MPLS and they're using multi-protocol BGP. So leave those out of there. We looked at how we put the interfaces into the VRFs, right? Or associate the VRF to an interface, however you want to look at it. We looked at the routing tables and how we see the different routing tables. We looked at a routing protocol, OSPF, and how it is VRF aware, and how each process ID for each of the VRFs needs to be different, in addition to the router ID, which needs to be different. We then associated a lot of those interfaces to the VRF, tested reachability, and we have it from end to end. All right, thank you so much for watching, and I hope to see you in the next video.